Okay, so now let's go with the measurement thing. There were two types of measurements used in the earlier parts of the world, the English system and the metric system. They are still used but not acceptable everywhere, as now there is a new standard acceptable system of units called the SI unit system. Let's discuss about the SI units in a bit more detailed way. As we have studied in the previous years, there are 7 different base quantities in the SI units. Let's just quickly define them. The first one being unit of length. We know that the unit of length is meters. How should this write? Meter. As unit is meter. So 1 meter is defined as the length of path traveled by light. The length of path traveled by light in vacuum during time interval. So here it is on, you see, vacuum. So let's just define it once again. 1 meter is the length of path traveled by light in vacuum during the time interval of 1 upon 299 792 and then 458. I guess it's visible from there. So 1 meter is the distance traveled by light in vacuum during a time interval of these many seconds. I mean this part of a second. You can imagine how fast that is. So now the second unit being the unit of mass. So we all, some of us are confused that whether the unit of mass is kilogram or gram. But the SI unit, meaning the standard unit of mass, is defined as kilogram. So now you know that, but don't confuse it with gram. Gram is not the SI unit, it is just a unit. So kilogram is basically nothing, just a weight of a prototype defined at the SI unit, the system, the council there. It's just the weight of a prototype. Then let's go to the third unit, the unit of time. As we all know, it is seconds. I write second only, not S. So 1 second, we could have defined it like the way the time taken by light to travel the distance of this much, but that's not good. You can't define one thing with a relation to another. We have to try something, a unique, which is not related to any other thing. So if we have done that, then meter and second would have been interrelated with each other. So that's not acceptable. So the unit of time is defined as the duration of, again a big number here, 9192 and then 631 and 77C. These many periods of radiation. Now here's a new thing. 1 second is the duration of these many periods of radiation of hyperfine levels of the ground state of cesium-132. We all know the cesium is 132. There's an isotope of that cesium. So when cesium reacts in a hyperfine state in ground level, so that's from a detailed thing. We'll discuss the ground level further in next of the chapters. So these many radiations of cesium-132 is done in 1 second. So you can think of how fast one radiation would have been. Basically that's it. And then next one being unit of electric current. Yeah, most of us are also confused in the electric current one also, like whether it is volt, ampere, watt. Even some say that it is horsepower. That's kind of funny. So, unit of electric current. Well, that is nothing but ampere. Now, let's just define 1 ampere. 1 ampere is the constant current which which when maintained through two straight parallel current carrying conductors, straight and parallel. So this means the distance here is equal to the distance here. Now these both are having current carrying conductors of infinite length. I mean, this is just theoretical, not possible practically. I mean, infinite length, how can you bring that? Of infinite length, kept 1 meter away. So the distance between these two is equal to 1 meter. Okay, so let's just do it again. 1 ampere is the constant current which, when maintained in two straight parallel conductors of infinite length of negligible cross section, I mean that's obvious, and placed 1 meter apart in vacuum, would produce this current a force of 2 into 10 to the power of minus 7 Newton per meter of length. 7 Newton per meter. This is the force produced between these two. These both are kept in vacuum, have negligible cross section, are straight, have current, are parallel, and obviously infinite of length. Okay, so let's just continue all this. Yeah, I know I'm short of space, but what to do? Okay, the next one, unit of temperature, or we can write the unit of thermodynamic temperature. Both are same thing, but thermodynamic is more preferred. It is a bit more, specific thing. The unit of thermodynamic temperature. Okay, it is now defined as, it is always defined as Kelvin. It is Kelvin, not Celsius. There are confusions about that also. The unit of thermodynamic temperature is Kelvin. Now Kelvin is the fraction of 1 upon 273.16. 1 upon 273.16 of the thermodynamic temperature of the triple point of water. Now this is equal to this of triple point of water. Now you all must be thinking, what is triple point of water? Okay, so let's just let's define the triple point first. Okay, so basically triple point is a, you must have guessed that it is a temperature. Yeah, it is. Actually, it is a combination of temperature and pressure. Triple point is a point of temperature and pressure where where all the three states of matter exist with each other, coexist. Like the triple point of water is 0.01 degrees Celsius. This is the triple point of water. At this temperature, water, ice and steam, they will coexist. All three of them can be found at this temperature. There is some pressure also, which we will study obviously further. So this is triple point of water, this temperature. Now you know how to convert it into Kelvin, we can do that easily. So now I guess you all have an idea about triple point of water. What is triple point of any matter? The point of temperature at which all the three states of the matter coexists in thermodynamic equilibrium. Thermodynamic equilibrium basically means that all the three states are there: the solid, liquid, and the gaseous one. Okay. So now continuing it, the unit of amount of substance. Now it is mole. You all must have heard that before also. 1 mole, 2 mole. Now 1 mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 12 grams of carbon 12. You know, C12 is having the molecular weight of 12 grams. You all know that. So the number of entities in this, the number of molecules in these many grams of C12 is equal to 1 mole. Okay. So now there's one small little thing to note here also. When mole is used, the elementary entities must be specified and may be atoms, molecules, ions, electrons, or other particle or specified groups of such particles. Okay? We need to define what the particles are when we are using the word mole with it. Okay? So just let's now continue it. The next one is the unit of luminous intensity. Now unit of luminous intensity is candela. Okay, candela is unit of luminous intensity, and 1 candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 to the power 12 Hertz. So let's just make a source here. Source having monochromatic radiation, you mean like if you take it the visible light, monochromatic means of only one color or one particular wavelength of frequency. So here it is given that frequency is equal to 540 into 10 to the power 12. This much is given, and that has a radiant intensity in the direction of, in the dimension 160, 1 upon 683rd. I can simply say 1 upon 683 watt per, per meter. Or in a more, you can say a more detailed way, we can write watt per steradian. These terms are more scientific to be used, and these are also acceptable everywhere. So let's just define it once again. 1 candela is the luminous intensity in a given direction of a source that emits the frequency, the monochromatic radiation of frequency 5 into 10 to the power 540 into 10 to the power of 12 Hertz, and that is radiant intensity, radiant intensity in the direction having 1 upon 683 watt per steradian. So that's a difficult thing to remember, but still what to do. Okay, so now these were the fundamental basic units, and now there are other things also like speed, density, force, acceleration, etc., which are derived from these 7. These were the basic, and other things are also derived from these things. And now we need to know the prefixes used in the SI system. We need to learn them. That's more important. Okay, so let's just simply start with it. This is known as block 2 or small y. This is known as Z2 Z. This is, we need to learn them. Okay, so now I know. Okay, so these are the prefixes used. Like if we want to write that 1/10th of a kilometer, okay, or we should write that 1/10th of a meter, all that stuff. Centimeter, what is 1 centimeter? That is 1/100th of a meter. So we can write that. We need to learn them by heart also. So these were the negative powers of 10. I mean 1 upon number is there. Similarly, there are the positive ones also. So I'm not reminding that. Let's just remove these and these. And we will also remove the negative signs. So here you have the positive ones. It is your turn. Now these are denoted by capital, meaning the capital letters. Etc. The X. The vector. The tera. Now here comes the computer ones, terabyte, gigabyte, megabyte. Then mega and I guess kilo. K is denoted by small k. I mean the kilo is denoted by small k. Remember that. Kilo, hecto, and there is one more deca. Okay. So I mean you can all understand that, like if you have to define 1 kilometer, that is 1,000 of a meter. 10 to the power of 3 goes for 1,000. So this is 1,000 of a meter, kilo of a meter. Okay. So I mean that's a bit easy to understand. So it's now I guess we need to learn the table, prefixes, and this is very important. We need to remember them. So basically that's it for this.